Today we are going to learn about a chemistry classic. We're going to learn about titrations. And with this, we get to add to our list of reaction types. So think back when we were learning about those reactions. We learned about synthesis reactions, decomposition reactions, combustion reactions, and now we're going to add to that list the acid-base reaction, which is also called a neutralization reaction. So a neutralization reaction or an acid-base reaction is the chemical reaction between an acid and a base. And when we remember that we need to be able to predict the products of those different reactions, when we predict the product of a neutralization reaction, we know that we are going to create a salt, which means it's going to be an ionic compound. So remember that ionic compounds have a metal and a nonmetal. Okay? The metals give away electrons to the nonmetals. The nonmetals take those electrons. So now they're a little bit positive, a little bit negative, so they hang out together due to that attraction from those charges. Okay? So we're going to create a salt, which is an ionic compound, and we're going to create water, H2O. So your neutralization reaction is going to look like this. Acid plus base results in salt and water. Here is an example. So we've got hydrochloric acid. We know that's an acid because it starts with the letter H. And then using our ionic nomenclature rules, because Na, sodium, is a metal. So since the first thing is a metal, we know ionic naming rules. So this is sodium. OH, we have to use our polyatomic ion chart because that's more than one element. And we find that OH is known as hydroxide. Okay. We know that this is the base because OH, if it ends in OH, that's your base. Okay, and it's going to create sodium chloride and water, but if we're using our proper nomenclature rules, we know that this is dihydrogen monoxide. Hydrochloric acid is a strong acid. Sodium hydroxide is a strong base. So you create a neutral salt. So when you mix a strong and a strong, your salt will be neutral. But you can also use a weak acid with a strong base, and when that happens, the salt that you create will be basic. Okay? The opposite can happen too. You can use a strong acid with a weak base, and then your salt will be acidic. Because neutralization does not mean a pH of 7. Okay, so be careful with that. A lot of people like to think, okay, you're neutralizing, you're mixing an acid and a base, you're turning it into 7, neutral, because it's called neutralization. So just be careful. It doesn't always mean pH of 7. All right, so let's talk about titration. If you guys go to college and you take chemistry in college, you will perform a titration lab where you actually measure the pH and walk through the process of this. So you'll calculate first, doing some practice problems like what we're going to do, and then you'll have your lab day where you go in and you actually perform it. Okay, so what is a titration? A titration is a method in which you use a standard solution, so one of which you know the concentration of it, you know the pH of it, and you use that to help you determine the concentration of an unknown solution. And the key point in a titration, the key step is when you reach the equivalence point. This is your end point. This is when you're done and you're ready to do calculations. So the equivalence point is the point at which you have added equal amounts of hydronium ions and hydroxide ions. Okay, so that's where it's equal between the two solutions that you're using. And we know that we have reached that point in two ways. One is visually. You will see a dramatic color change in your solution. Here's a really quick video clip to show you. Notice he's adding drip by drip by drip, not a lot of change, and then boom, after just a few drips, bright hot pink. Okay, so that is your equivalence point. See the dripping in, no color change, so it's not equal yet, still dripping, starting to see some color change, and then boom, color change. That's your equivalence point. Okay, so that's the visual that you can see to let you know that you have reached that endpoint, that they are now at equal. Okay, the other thing that you have is a dramatic change in pH. Now, this is not something that you can visually see, the actual pH measurement, but you will use an instrument that measures pH. And as you add this, you'll be able to see it graphing in real time and be able to see that dramatic, like you will add one drop and it will dramatically increase the pH. And right in the middle of that giant leap is your equivalence point. Here is your equation for doing a titration calculation. Okay, so at the end point, your moles of hydronium ions will be equal to your moles of hydroxide ions. And our equation here is MVN equals MVN. The M here, that's a capital M, so that's going to stand for your molarity. So we've been practicing with molarity recently. Your V is going to stand for your volume. And your lowercase n stands for the number of hydronium ions in the acid or the number of hydroxide ions in the base. Okay, so that N, one is for the acid, the other one is for the base. Okay, so let's look at a practice problem and see how we're going to figure this one out. Okay, so here's our problem. 42.5 milliliters of 1.3 molar KOH are required to neutralize 50 milliliters of H2SO4. Find the molarity of the H2SO4. Okay, so we know the concentration of our base. We do not know the concentration of our acid. That's what we're trying to figure out. Okay, so what I'm going to do is break up this information for information about the acid and information about the base. Okay, so for our acid, we don't know the concentration. That's our unknown. That's our X. That's what we need to find out. Our volume is 50 milliliters. And our N is 2. Now, where did that number come from? So remember, the N is the number of hydrogens for the acid, the number of hydroxides for the base, and it comes from your chemical formula. So you got to remember how to make those chemical formulas accurately, checking those charges. So if you need to go back and study your acid nomenclature and your ionic nomenclature, please do take the time to do that if you need to. Okay, but in this problem we were given the proper chemical formula, and so we say how many H's are in the acid. There's 2 of them, so that's where that number 2 came from. It came from the number of hydrogens. Okay, next we need to fill out the information for our base. So our concentration, our molarity for the base is 1.3. Our volume is 42.5. And our N, how many numbers of hydroxides do I have? There is no subscript at the back of the hydroxide, so that means, understood 1, I only have 1 hydroxide. Okay, so that's where that number 1 comes from. How many hydroxides? Okay, and then now I can solve for my unknown. So here's my equation, MVN equals MVN. Okay, all of the acid information goes together, all of the base information goes together. So you have to be very careful plugging in your numbers. You want to make sure that you don't accidentally mix those numbers up. That's why I like to go ahead and separate out what I know so I can make sure I plug them into the proper location. Okay, so on one side I have all of the information for 1, so my unknown M, my 50 milliliters, my 2, and on the other side I have the information for my other chemical, so my 1.3, 42.5, and 1. And then now I just use my algebra skills to solve. So I'm going to start by multiplying everything on this side. So 1.3 times 42.5 times 1. And then on the other side, I'm going to go ahead and multiply that 50 times 2. And then I would have to divide this answer by this answer. Okay, and it's okay for me to leave milliliters here since they're both in milliliters. I didn't need to convert because those units are going to cancel off and they don't have to be combined with another. So it's okay to not convert here as long as they're both equal. Now if one was liters and one was milliliters, then we would need to convert one of them so that their units matched. But since they already match, they're going to cancel off and we are good to keep going. Okay? So my final answer is 0.55 molar, okay? Because my milliliters canceled off and I was left with my molarity unit. Why 0.55? We had to round to get there because up here my 1.3 only has 2 sig figs, so my answer has to have 2 sig figs, okay? If you worked this problem out and you did not get this answer, please get into contact with me so that I can help you figure out what's going on. It may be a calculator issue, it may be an algebra issue, so if you need some help, please get into contact with me. That way you will be able to do the independent practice next.